So today I'm going to explain the session plan is just like this. Command line arguments, we'll take it later, okay, after the packages. So as of today, we will be going through polymorphism, inheritance. Inheritance is already done, so I'm not going to talk about it. This one, interfaces, okay, and then packages, command line arguments. I hope something I'll complete it by today. Um, by next class, I think I'll be done with module 1. Okay. Hopefully by that time I'll be able to complete all the Java related stuff. Okay. So let's get on with it. Method overloading. So here, let me first start with okay, more than what is method overloading. So basically method overloading is something which we there it has the same function name or method name, but arguments might be different. Okay. A return type cannot be different. Okay. The argument list could differ via number of parameters, data type of parameters, sequence of parameters. That means the integer could have been the first and float could have been the second in the one of the methods, and in the second method it could be the float could be the first parameter and integer could be the second parameter. Okay. And we cannot have different how return types. That would really kill the polymorphism, because it would never come to know what it's supposed to return, and that would really be a challenging if it happens. Calls to overload methods will be resolved during compile time, also known as static polymorphism. More than one method within the same class have the same name but differing in method signature are termed overloaded methods. Now this one, see, this is what I'm trying to tell. So let's say, okay, let's say I have a void here which takes integer a, integer b. Same add, it takes integer a, float b. Now this is second time it is doing the same thing. Okay, this I cannot have these two again and again, but I could have had float a, float b here, and integer a over here. That is another signature by itself. This is the third one. Same method, but it takes 3 parameters to it. Okay. Now that would be something which we want. So something which would be overloaded methods, called as overloaded methods. Okay. Now void add integer a, float b. Void integer add integer a, float b. This is something which cannot be done. Why? Because same signature cannot return void and int. Why? Because it will never come to know what happened. Okay, so we should never do it in this fashion. The top method signatures are fine, but the bottom ones are not fine. Now, one second, I'll just need an eraser here. Okay. Okay. Now, inheritance. I talked about it, but let me go through this once again. You will realize when the inheritance, when it is of a easy relationship. For example, student cat is a type of animal. Is a, remember the way when we say is a relationship, that means we have when it is very similar to something, we say it is a kind of something. One of them is a kind of something. The parent class is termed as superclass and the inherited class is the subclass. The keywords extends is used by the subclass to inherit the features of superclass. I think yesterday's I uploaded one video on Java inheritance. Please take a look at it as to how it's supposed to be how it's supposed to be done. Okay, it has a code. Based on the code I have done it, so it would be good for you guys to look at it. Okay, for you to understand about that. Okay. um, Next is multi-level inheritance is allowed in again, this also I spoke about it. This is multi-level, this is multiple. This is not allowed in Java. The right one, it is not allowed. Paternal, maternal, child. This is allowed. The first one, grandparent to, this is allowed. Okay, grandparent, parent can inherit from grandparent, child can inherit from parent. So multi-level is allowed, but multiple is not allowed. This is not allowed. Okay, so now this is just an example. Yesterday I showed the whole in the sense the code itself. Take a look at it. Okay. uh, Method overriding. This is something which we need to know. Overriding is something which, for example, parent might have said something about that it will do certain job like that, but a child can override that particular part of it. For example, you all would have overridden what your parents would have told you to do, but in a way they would have told you to come by, let's say you do like this, but you would have overridden that command and did your own way. So that is overriding. Okay, so how do you do it? So like for example, in the doctor, the treat patient by the doctor object could be different. Similarly, a surgeon who has inherited from the doctor thing, but he treats patient differently. This doctor actually gives tablets. This guy actually cuts the patient. So the treating the patient is different by a physician versus a surgeon. So these are two different ways. So overriding a doctor, the same method, treat patient in both these two different objects are different. So is a good example on overriding. Okay. Some rules in overriding: the method signature, method name, parameter, list, and return types have to match exactly. So while you are overriding, you cannot do method or parameter. What was the earlier one which I said? Overriding and the previous thing. What was that? 1 second. Huh? Yeah. Okay. So overloading. Okay, that you cannot do it. Okay. Now dynamic binding. This is something which if you understand how to do this, it will be very good. For example, can we do this doctor object, but I'm creating a new surgeon. Surgeon is the child class out of doctor, but I'm creating a doctor object is equal to new surgeon. This is something called as reference to a superclass can refer to a subclass object, but it cannot be true the other way. A sub object cannot be created using the parent object. Okay, that would be very disturbing, right? A doctor object, which is the parent class, can be created using a surgeon. Okay, because it at the time surgeon has inherited from doctor, it can be created, but not the other way. So now we can say that object.treat patient, which version of the method is called? It calls the surgeon's version of the treat patient method as the reference is pointing to a surgeon object. Okay. If a base class reference is used to call a method, the method to be invoked is decided by the JVM, depending upon the object the reference is pointing to. That means at the time of runtime, it will actually do a casting as to which particular method I am supposed to call. So the JVM actually decides. It's called as dynamic or runtime polymorphism. So it is another way of the polymorphism where which particular method needs to be called and at what time. Okay. Now, super. What if the treat patient method in the surgeon class wants to do the functionality defined in doctor class and then perform its own specific functionality? That also can be done as long as I call it using this super.treatPatient. That means first call the parents treat patient and then call the specific surgeon's treat patient within the treat patient. So that is also can be possible. Okay. So we'll look at example if at all I type these things. Okay. Now let's understand these two types of polymorphism: static versus dynamic polymorphism. A function overloading within the same class more than one method having same name but different in signature. It's called as function overloading. Resolved during compilation time. Return type is not part of the method signature. So this is static. Dynamic is polymorphism has two forms. One is overloading and one is overriding. Overriding actually is the dynamic one because at the time of runtime it actually decides which one to call. Keep the signature and the return type same. Method in the base class is redefined in the derived class. Resolved during runtime. So which method to be invoked is decided by the object that reference points to and not by the type of the reference. At the time of runtime, whichever the object refers to, that particular method is called rather than what is supposed to refer for. Okay. So this is the two types of polymorphism. Now, I hope you understand. I just will stop right now. Okay. And I would like to take any questions right now here. Okay. Before I go ahead, if there are any questions, it's better to answer right now. Do you have any question now? Please type it if you have. Girls, Vinay, any questions? It off. Okay. So here let me again start off. Abstract. Again, going through this. Consider a scenario where you have a generalized class called shape, which has two subclasses, circle and rectangle. Okay, circle and rectangle have their own way to calculate area, right? So shape class cannot decide how to calculate that area. So it only provides a guideline to the child class that such a method should be implemented within them. Now this is the same, I have shared the partial code in the roster, which you should be able to go if you have it, go to drive.google.com and there you will see a partial code of the code that I have shared with you. All of you have to work on it and submit it and put it in your own roster folder that I have created it for you in your drive. Okay, once you share it, I will be able to see it. Okay, hopefully you will do that. I have put two partial codes. You need to complete the code and submit it to me. See that you run and see how the outputs are coming. Based on that, you will know whether you learned about the polymorphism and abstract and that stuff. Okay. Now here there is two things that it has to calculate. One is the calculate area, but shape doesn't know how to calculate the area of circle and rectangle here. In that case, who should implement the calculate area? Circle and a rectangle should do its own job of calculating the area, isn't it? Shape doesn't know because shape Which shape it's supposed to calculate the area, it doesn't know. So all its shape does is declare a particular method called calculate area, and it will declare it as abstract public void calculate area. It will not implement the shape class, will not implement this. Once a particular method does not get implemented in a particular class, and I put this keyword called abstract, the whole class becomes abstract. So that is another thing. So the whole class become abstract. So I need to put this keyword called abstract in front of the class shape. Now whoever inherits from this particular class has to implement that particular method. If even the subclass does not implement that method, the whoever inherits from that subclass also, that subclass needs to implement it. Okay, the class which does not get implements the particular method cannot be instantiated also, because it doesn't know what to do with that particular method. If you by mistake call that calculate method, it will not know what to do. So by default, an abstract method makes the class abstract, and once the class becomes abstract, you will not be able to instantiate that particular objects of that particular class. So whoever inherits from that particular class will be able to do will have to instantiate that particular class, and then implement that particular method within that particular class. So let's look at particular this thing. Now this particular class has become abstract, right? So this particular class has become abstract. Okay, that means I put a keyword abstract, this particular class becomes abstract, and this there are certain code within, there might be some methods within this particular class which has implemented some code within that is fine. But since one of the method becomes abstract, the whole class becomes abstract. So that is the uh, thing that happens when an abstract class is used. Okay. Now, the following cannot be marked with abstract and modifier: constructor, static methods, private methods, methods marked with final modifier. They cannot be put with abstract. The one which you thought supposed to be implemented by a child, that only becomes abstract, not the rest of the methods within that particular class, just because it is abstract. So it cannot happen that way. Okay. Now, final modifier has a meaning based on its usage. For member data and local data and methods, primitives read-only constant, object reference is read-only. That means you don't want anybody to touch the value that is being assigned to that particular data type, or that particular variable, instance variable, or instance variable. So you don't want anybody to touch. Neither it also applies for the methods and classes also. What does it mean? If it applies to a variable, it is a constant. Nobody wants to touch the value of it. But if it is for a method, you don't want anybody to override that particular method. So no dynamic polymorphism on that particular method. But if you put a final on a class, you are trying to tell everybody else that you don't want anybody to subclass out of that particular class anymore. That is the final class. Nobody should do a inheritance out of that particular class. That is the meaning of the final. So the final applies. Final has a meaning on different things, on a data type, on methods, on classes. What it means is different for in a different ways. Okay. Interfaces in Java has a different meaning, but we will go through here. Let us consider a design option. Class dog has been designed, which is a subclass of animal. Okay. Dog is also a pet, and it needs the behavior of pet. So should we place the functionalities of a pet in a class dog? Then what happens when we design a class, design a class called cat, which extends from animal and is also a pet? Should we repeat the pet functionalities again in the cat class? So the functionalities are the same as long as the meaning of a pet, what it means to be a pet. If it is to be the same, if it is the same, then we have to put this particular functionalities as part of the animal pet class, not the animal class, but the pet class, which is an interface which can be implemented according to the dog or a cat or something like that. For that means it is not a subclass of the class called animal. Okay, it is not a subclass of the, it is not a subclass of this animal, but there are certain behaviors that a pet behaves, that I want to implement against a dog. Okay, the dog has been extended from animal, but dog is a pet which has certain functionalities which it needs to apply. In the same thing, cat is also a pet. I want to implement certain functionalities to the cat. Cat is an cat is subclass of animal. Okay, but since it is a regular cat, a domestic cat, it is a pet. There are certain functionalities I want to implement, and those functionalities could be common for all the pet dogs. Okay, so I want to, if I want to implement that, it better be a some kind of a functionalities which is outside of the animal class. So in that case, I need such things where, one second. Okay, so what is the solution? If we separate out the functionalities of pet into a separate class, so class dog now extends for two base classes, animal and pet. But since multiple inheritance is not allowed in Java, the best way to do is through the interface. How do we do that? So this is not allowed. I can't extend the dog from animal and pet. I know that this is a little bit white in nature. Okay, so I can't inherit it from. So I have to inherit something like a some other class, but it is not extended. So how do we do that in Java? Is through the special class called interfaces. So interface is a rescue for us. So dog extends from animal but implements the functionalities from a different class called pet. So this is how it actually implements. So all methods in interface are implicitly public and abstract. The class which implements the interface needs to provide functionalities for the methods declared in the interface. That means this guy interface pet has these two functionalities, but they are not implemented. They are not implemented. They have to be implemented by the class dog, which extends from animal, implements the pet. That means this interface has certain functionalities which it has to be implemented by the dog. How friendly that behaves, or how the playfulness of a particular animal depends upon what kind of an animal it is. Dog might might make different friendly gesture. Cat makes a differently gesture. So the implementation has to be different based on the type of a animal, type of the animal, which could be dog or a cat. So that's how the interfaces are implemented. An interface may define data members, and these are implicitly public, final, and static. That means there might be data members also, which are public, final, and static. That means it cannot be touched. An interface cannot have private or protected members. An interface can extend from one or many interfaces. That do it can interface again. It can implement employee, comma friend. Like for example, a class person extends living being, implements employee and friend, comma spouse, comma something else. Okay, that can be applied onto a class, but extends is only one time, but implements can be multiple. So interface readable, the interface can extend from multiple interfaces. There it is. A class can extend from a living being. Okay. Class can extend from a living being, implements from multiple interfaces. Interface can extend from multiple interfaces. Extends animal, comma, extend something, something can happen. So this is something which you should not get confused. Okay, so it can be it can extend from multiple interfaces, but a class can extend only one class but implements any number of interfaces. An interface can extend from one or many interfaces. This is very important. Okay, and finally, an interface cannot be instantiated. An interface reference can point to objects of its implementing classes. The same interface can be implemented by classes from different inheritance trees. What does it mean? Example, parrot is a bird, but also a pet. Class parrot extends bird, implements pet. Interface pet is being used by both dog and parrot. It can be done. So that's what it means. Interface cannot be instantiated, but can be inherited for different classes. Okay, extend can have only from one extended from one class, but interfaces can a class can implement multiple interfaces. So this is what is related to interfaces. Okay. So what is the difference between abstract class versus interface design choice? Use an abstract class when a template needs to be defined for a group of subclasses. Ensures that no objects need to be created from it. Okay, and that means a similar kind of blueprint needs to be implemented in different classes that you can extend it from an abstract class. But different kinds of functionalities that you want to be that your class needs to be implemented, that needs a that needs to be interfaced, or interface can be used in that situation. So this is a very good point. And typecasting. Now this okay, let's complete this part because I kind of referred it. A base class reference can point to objects of its subclasses. So this is very important over here. So let me do this. So for example, okay, so a base reference, okay, here the base reference is a person. Okay, uh, class student extends from person. There is nothing here in the person, but can I really create a person reference of a person object using the student as a using the student constructors? Can I really do that? So that's what it is. In the static void there is two reference variables. One is a person and one is a student. Now person is parent, student is the subclass. So person is equal to new student. Fine. Student is equal to new person. Not fine. Why? A child cannot instantiate a parent. That you all know, right? A subclass cannot instantiate a parent object, but a parent can instantiate a subclass, a child's class. And again, it has to be in a proper. Let's say, for example, I can do this, but if I put this casting around it, then I can do it. The student is equal to student of new person, fine. But I cannot use it like this. I can use it in another form also, which is, for example, I can type it over here. Okay, person is equal to new student. This is anyway, it is done here. The first thing is done. What I wanted to show was here, this one. That also can be done, right? This also can be done. This one, okay. This also can be done as long as I cast that to the one which I am trying to instantiate. So whatever this particular reference variable is pointing to that type, if I cast it, explicit typecasting, that is also fine. As long as these two can, this is how it can be instantiated, it is fine. Okay. So if I go now, let's see what is the next thing, because I need to stop the recording. So let's see. Now this I will do it in the next class. Packages is a very special one, so I will not do it right now. This ends the our today's class. I would like to ask any, if there are any questions, can you unmute yourself and ask any questions? And moreover, next week there will be a quiz. Okay, quiz. There will be some. I uploaded the two unfinished code in the roster which I shared it. I think if it is not shared, let me know, because I need to properly share it so that you can get the unfinished code, and you need to put it in your respective folder so that I can see it. Okay, that is how the roster is set up. So please see that you are able to do it. If you have any doubt on that, please let me know. Any questions before I stop it?